I am Chidi Zimbezi. Please help me. Thank you.
Shame I love this video. It's like, this is calculus, please help me, I don't know what I'm doing. I'm gonna help you out. This is a great question because it's one of these horrible functions that has x in the denominator, and then you have to use the first principles formula, and it just sucks. So let's go through this, and hopefully I'll make it a little bit simpler for you. Let's take a look. It says, if f of x is equal to negative 2 over x, determine the first derivative of x using the definition. So the moment you see the definition, you know you have to use the limits definition. You can't just use your differentiation rules. You need to use the definition. So remember, f prime of x is given to us as the limit as h tends to 0 of f of x plus h minus the original function of f of x all over h. Okay, so because this function has x in the denominator, if I try to do this immediately all over the fraction, I'm going to get a little confused. So I'm going to first find out what this numerator would be in its simplest form. So if I say f of x plus h minus f of x, it's going to give me, if you're trying to find f of x plus h, what you do is in your original function, whenever you see an x, you substitute x plus h. So f of x plus h is equal to 2 over x plus h, but there's a negative, of course there's a negative, x plus h. Okay, so this whole expression here is f of x plus h. Now we need to subtract the original function. So we're going to have minus negative 2 over x. Don't forget that sign there. The original function has a negative. So let's carry on and simplify this. We're going to get negative 2 over x plus h plus 2 over x, because remember, a negative multiplied by a negative is a positive. Okay, so now to add these together, we need to find the common denominator. Remember, if you can't find a common denominator that's simply one of these two, you need to multiply them by each other. So this first one, we need to multiply by x. What you do to the bottom, you do to the top. So we're going to have negative 2x all over x plus h multiplied by x. The second fraction, we need to multiply by x plus h. What you do to the bottom, you do to the top. So we're going to have 2 into x plus h all over x into x plus h. Okay. So now we just keep going and we simplify this out. I'm going to just simply rewrite the numerator in terms of just the numerator. So we're going to have negative 2x plus 2x plus 2h. And the numerator is all the same thing. It is x into x plus h. So we're going to have x squared plus xh. Okay. We can lastly simplify this by saying negative 2x plus 2x gives us 0 plus 2h. So the numerator simplifies to just 2h, and we're left with a denominator of x squared plus xh. Okay, and that is equal to this numerator at the top here of our limit. So now we can simply put that into the numerator. So therefore, f prime of x is equal to, we still need to take the limit as h tends to 0. So we're going to have this in the numerator, 2 over x squared plus xh, and remember, all over h. Okay, so now the idea is, oh, it's 2h over there. The idea is to get this h out of the denominator, because when we take the limit as h tends to 0, remember you substitute h equals 0 into wherever there's an h. So if we have h equals 0 down here, we're going to have an undefined fraction. So let's look at this. For those of you who can't automatically see it, if you have a fraction over a fraction, it sometimes looks a little bit ugly. So to rewrite this as two fractions, we're going to have x squared plus xh as the denominator, and this is all multiplied by 1 over h. Okay, so if we look at this, we can cancel out the h's because they're going to divide into each other, which means we still have the limit, because we haven't taken it yet, as h tends to 0, of 2 over x squared plus xh. And now you see we've managed to get it into a format that the h in the denominator does not mean that this is going to be undefined if we substitute h equals 0 into it. Okay, that's the whole idea of this first principles definition, trying to get away from the h in the denominator being a problem if we substitute 0 in. So now we can take the limit. If we take the limit, it means we remove this notation and we substitute h equals 0 into our function. So we're going to get 2 over x squared plus x multiplied by 0. Lastly, we can see that that's going to equal 2 over x squared plus 0 multiplied by anything is 0. So we're going to get 2 over x squared. And the way you can check if you've done your first principles right, what we found from all of this is that f prime of x is equal to 2 over x squared. You can check it by simply applying your differentiation rules. If we do that, remember, f prime of x is equal to, if we write this out in its generic form, f of x is equal to negative 2 multiplied by x to the power of negative 1. Because remember, if we take x into the numerator, it's got an exponent of negative 1. So if we just use our differentiation rules, you multiply by the exponent, so you get negative 1 multiplied by negative 2 multiplied by x, and then you subtract 1 from the exponent. So we're going to get 2x to the negative 2, which is equal to 2 over x squared. And that is exactly what we got here. Okay, so when you have a function and you need to differentiate using first principles, sometimes it's easier to work out what that f of x plus h minus f of x is first, and then substitute it into the formula. Otherwise, if you feel comfortable just merely doing it straight away with the limit, have at it, do that. But remember, with your first principles, go through all of them until you get to what you think is the first derivative, and then derive or differentiate the function using your differentiation rules. If the two match up, it means you've done your first principles properly. Okay.